Think about the last time you tried to open a bank account, reset your password, or verify your ID online. Chances are it involved endless forms, verification emails, and digging through your wallet. We've all been there, and honestly, it feels a little bit outdated. But right now, something big is happening in finance. Banks and fintechs are moving away from passwords, security questions, and traditional ID checks and replacing them with you. Your fingerprint, your face, your voice, your behavior. Biometrics is becoming the new key to finance. They're faster, they're more secure, and they reduce fraud in several ways. This shift isn't just a small upgrade, it's transforming how people access money, how companies verify their customers, and how security will work for the future. And this is a perfect lead into my project, which simulates Face ID, showing how it's stronger than traditional passwords and how it's going to be for the future of finance. Okay, before we get into the technicality of my project, we first need to understand what is biometrics. So, the simple definition of biometrics is using an individual's unique characteristics and traits to identify them. So, how exactly does it do that? We're going to take an example of your phone. Mostly everyone has Face ID on their phone, and how does your phone recognize you from other people? So you first send in some initial photos, and what it does, it doesn't necessarily take a snapshot of your face and compare it. What it does is it takes her face and it maps out everything on her face in numerical values. It'll take every single detail, the curve of her jawline, your nose, the distance between your eyes, every single detail it can take. Now, what it will do is when you start to log into your phone, it's going to compare your current numerical values with the initial ones, and it'll have a threshold. So let's say 80% of the numbers match, then it'll give you your access verified. And let's say less than that match, then it's going to say it's not the same person, access is denied. So we're going to use a mini example on the screen. We have two sentences, I love dogs and I love cats. And we're going to see if a program were to try to differentiate the two, how would it do that? So first, what it would do, just like a face, it would map out everything in numerical values. So it mapped out the two sentences and numerical values. For example, the letter I was assigned the number 1, the word love was assigned the number 2, the word dogs was assigned the number 3, and the word cats was assigned the number 4. And if a program were to try to differentiate the two, it would see that dogs and cats, so the number 3 and 4 are different, and that's where it would differentiate those two sets of numbers. So that's a basic example of how a program would do that. Obviously, when you go to Face ID, it's not really different. The only difference is how you would differentiate the numbers and how many numbers there are. So we're going to get into that project right now. Okay, so this is what my project looks like. So as you can see my face. So there's a camera working, and what you can do is first the user must click this capture enrollment, and that'll be their initial photo. So I already took my picture right here, and what it did is it mapped out all of my facial features and numerical numbers. And now, obviously, in the code, I can't do this manually. I'm not a coder, but there are libraries out there that can help you. So I just use a library and it would do it for me. So I have all my facial features mapped out here. Now I'm going to do a capture verify. So this would be your day-to-day logging into your phone, that second picture, and it's going to compare it to that initial one. So I'm going to do it right now, and right here off the bat, mostly everything is green because I haven't changed my setting, I haven't changed my clothes, I haven't changed anything about my face. Time hasn't passed by, so everything is the same. Now, obviously, in a different scenario, I would have different clothes on. My hair would be different, my setting, my background would be different, and so that's why over here I have a threshold distance. So this means that all these numerical values will pass if it's off than less than 0.6. So for example, let's look at the first numbers. It's 0.06 and then 0.03. So now they're off by 0.03, but if they're off by zero point 0.6, then it would be access denied, right? It would be a red square because they wouldn't match. So that's why you have a threshold, because conditions can always change. So right now we're gonna get into the code to show the technicality part. It's not too complex, it's pretty simple. Now it is a little bit overwhelming, but we're gonna go through it one by one. So right now I'm using Visual Studio Code. It's a JavaScript platform and it's very simple. There's 3 files: HTML, CSS, and script. So your index.html, this is everything that's on the screen. So for example, if I go to this H1 face embedding, this is a text box. So these are all the physical things that show up on the screen. So over here, you'd code all the individual buttons, all the text boxes, and everything like that. So we're going to skip over this. There's not anything important here. Same thing over here. This is just styling. So making all your buttons look good, making the theme of your page look good, your fonts or colors, everything. Also nothing important here, but this is where the actual coding is. Script.js. So we're going to go through this one by one. So our first line right here is that library. So I personally don't know how to map out a face. Obviously, big companies like Google, Apple, they do that themselves. But I'm not a coder, so this library right here, what it does is I'm going to give that library the photo, so that initial photo, and it's going to map out all the numbers for me. So it's going to give me back those numbers, and I put each of those individual numbers in boxes. So this is the library to do that. These lines are basically taking all those physical buttons and putting them into variables so I can code for them. And as of right now, these are the numbers for the initial photo and the verification photo. Right now, it's set them to null because there is no value for them. And moving on, this function is to start up my camera, because I obviously do need to fetch that from the computer first and check the permissions. Like right now it says there's an alert, camera access is required, check permissions. So I can't really access my camera if I haven't given permission. So if anyone were to use the code, they'd have to do that. The next one is to load the models. You always need to load the models before you start your program, which is why I took my initial photo before filming, because all these models take a little bit of time to wait. So when I start up my code, it'll take about 2-3 minutes for the models to actually load and be ready to get information and help me out. Now over here, this is to format my numbers. Now I use a 128 float 32 array format. So basically it took all those numbers and it put it into 128 numbers. It's basically a low memory format that would allow me to use the code and run it a lot faster. So over here, what it's doing is it's taking the numbers and it's gonna format them into 4 decimal places. So we're gonna move on. And so this code right here is to take each of those numbers and put it into an individual box. So if we remember from my code, we saw when I took a picture, it would have 128 boxes of individual numbers. So to put it into those boxes to make it look nice, this is what it does. It'll put it into each of these individual boxes. And now this is a little complicated part. So we're using Euclidean distance to calculate the difference between each number. Now, what can be complicated here is, why wouldn't we just differentiate which number, how different are they from each other? Like, what's the difference between 2 numbers? Why are we using distance? What role does distance have in here? So to be more accurate, we use distance because we treat each number like coordinates, like mapping out coordinates on our face. And it's a lot more accurate than just using the difference between numbers, because if we were to do that, we get a lot of false alarms. Like, you might be the same person, but it'd still deny access. Or it could go the opposite way, where it would grant access to a lot of different people, which is why distance is a lot more accurate. And now over here, we're basically taking the photo from the camera and we're putting it into the library. And right over here, what it's going to do is when we click that enroll button, what if there's no face? If I just took a picture of the wall, it would say there would be an error and no face was detected. So we need to know, is that code really working? And that's what this piece of code does. It first detects if there's a face, then it'll take a photo. And once again, we also use a library for that because I don't have the coding skills for that. In this library will basically tell me, is there a face or is there not a face? Now, this is the big chunk of code over here. So what it's first going to do is once you take that initial photo, it maps out all the values. But now you need to take your verify photo. So what this first code does is it does the same thing as the last. When you click that verify button, it'll first say, is there a face or not? Once it does verify that there is a face, it'll take the photo, and once again, it'll put it back into the library. Now, in the library, it'll once again return back the 128 numbers. Then what we're going to do is, now that we have the two numbers, we're gonna match them, see if they're compatible with each other. So we create a tolerance. Like I was saying before in the example, do 80% of those numbers match? If at least 80% of the numbers match, then access granted. If less than 80% of the numbers match, then access denied. That's what this tolerance number is. It's kind of the distance between each number, how big that distance can be. Because if that distance is too big, then it can be a different person that's taking the photo. Then over here, what it does is it says const dist equals Euclidean. So we're calling that function to compare all the 128 numbers with the rest of the 128 numbers. Then it's going to check, do all these numbers meet the threshold? If yes, then access is granted. If no, then access denied. Then what we're going to do is it's going to display these numbers with highlighting, so that green and that red, basically. And then over here at the end, we're just loading the models and loading the cameras. So once I do start the code, it's going to turn on my cameras and start loading those models immediately. So that's a brief highlight of what my code is and what it does. So that's a quick gist of my code. It's not too detailed, it's not too complicated. We have the help of libraries to do the heavy lifting, to map on my face, to detect the face, and to compare the numbers. Obviously, that's something I can't code on my own, so libraries are always a great tool to help you out. And I'll link in the description all the tools I use to help me out during my coding process. And I want to get more into biometrics. Obviously, biometrics is powerful, it's fast, it's convenient, and it's shaping the future of finance, but unfortunately, it's not perfect. It has a big vulnerability because unlike passwords, you can't change your face. You can't reset your fingerprint. So once your biometric template is stolen or exposed, it's gone forever. So yes, biometrics can transform the way banks protect us, but it also introduces a new kind of risk. What happens when the very thing that proves who you are becomes the very thing that puts you in danger? And that's what I'm hoping my next project will answer that question. So thank you for watching, and I'll see you in the next one.